right, so here we go with part 2 of section 3.5, implicit differentiation. So what's happening in this section is, or in this part of the video, is we are still being asked to find a derivative, dy dx. But now, rather than finding the derivative of an expression, we're going to be given equations, and our job is going to be to find the derivative of those equations. Now, because this is an equation, there's going to be extra work involved. Right? So first things first. My job is to take the derivative of this equation right here. I'm hoping you're seeing the same thing I'm seeing. I am seeing 1, 2, 3, 4, and on the other side of the equal sign, 5 terms that we're going to have to take the derivative of. So starting on the left and working to the right, I'm just going to take the derivative term by term by term. The reason I can just take the derivative term by term by term is they are either all separated by addition or subtraction or by an equal sign. First term is y cubed. The derivative that I'm looking for is dy dx. So essentially the operator that is not written that would be sitting out there would be d dx. And since the variable of the first term does not match the variable of the operator, chain rule. So that first one's going to be 3 y squared times dy dx. Okay. Second term, again, the variable doesn't match, so it's going to be 2y, chain rule, times dy dx. Moving on to the third term, again, the variable doesn't match, so it's going to be a negative 5, derivative of 5y is 5, times dy dx. Moving on to the, what does that give me? The fourth term. Hey, the variable matches. It's x squared with respect to x, so that's just negative 2x. And then we run into an equal sign. And on the right-hand side of the equal sign, we have negative 4. And the derivative constant is always 0. So I'm to here. So I took the derivative, and now I got this mess. Again, a whole bunch of terms. 1 term, 2 terms, 3 terms, 4 terms, technically 5 terms still, right? Because we took the derivative of 5 things, so we should get 5 terms here. Right? You will notice that 3 of those terms have a dy dx in them, and technically 2 of them don't. So what I'm going to do is I'm going to take the one that doesn't and move it to the other side of the equation and take the ones that do and factor out that dy dx. And when we factor out that dy dx on the left, we're going to get the statement that dy dx times 3y squared plus 2y minus 5 is equal to 2x. Okay, why am I doing this? Well, because what's my job? My job is to find and to isolate dy dx. This is calculus, yes, but there's dy dx's all over the place, so I haven't really found or isolated for that dy dx. So now I need to do algebra to make that happen. Okay? So now I have dy dx times something is equal to 2x. I don't want dy dx times something. I just want dy dx. So how do you get rid of times something? You divide. And now that I've got it down to there, the next step, or the last step, should be to take a look at this expression on the right-hand side over here and ask myself, is there anything that I can do to simplify that? Now, the denominator is a quadratic, and so it might factor. But let me ask you this. If it does factor, is there any way that it will simplify or cancel with the numerator? And since the answer to that is no, then I'm not going to do it. Because I don't want to waste time doing work that isn't going to help me. And so I'm not going to try to factor something that isn't going to then cancel. All right, so before we move on, though, I want to talk about some things that are going to happen here. You should have noticed, I hope you noticed, that when you're handed an equation, you're going to have a left side and a right side in the equation. You're going to have a left side and a right side in your derivative on that first step. So right here, when we did that first step, I still have both sides of this equation. Right? Then I want to gather up all the terms that have dy dx's in them on one side of the equation and move all the terms that do not have dy dx's in them to the other side of the equation. And then we'll factor out our dy dx. That brings us to here. So I moved and factored. Then I divide. Now, stop and think about what's going to happen here. When I factor and then divide, this step right here will almost always, and I don't like to talk in absolutes, but I would have to work really, really hard to write an equation that when you got to that step, you didn't end up with a fraction. Now, there is the potential that it could simplify through algebra and end up not being a fraction, but it's going to have a fraction. In fact, I would say this. If you're working one of these problems and you get to the step where you isolate dy dx, and the other side of that equation is not a fraction, the first thing you should do is ask yourself, where did I screw up? That's how common it is. Or more importantly, that's how uncommon it should be to ever run across something that wouldn't have a dy dx equal to some sort of fraction. Now again, before you call me a liar or something and say, hey, I found an equation where that doesn't happen. Yes, I could probably spend some time and write something where it wouldn't happen. Okay? But more often than not, almost all the time, you're going to get a fraction there. And if almost all the time you're going to get a fraction there, the time that you don't see a fraction there, you should stop and go, did I screw up? Did I make a mistake? Okay? And then attempt to simplify that. See if there is a simple factorization of the numerator, a simple factorization of the denominator that will go somewhere good. So don't spend time trying to factor that denominator just because you look at a quadratic and say, oh, my algebra teacher taught me in 8th grade to always factor these things. No, that's a waste of time. Factor it if you see something in the numerator where you think that it might then simplify. If not, don't bother with it. Okay? Hey, remember this guy from earlier? X cubed plus y cubed equals 6x squared? Now's our time to take the derivative of that. Okay? I see 3 terms. So if my job is to differentiate with respect to x. All right, so I do notice something else about this one. The right-hand side is actually a product. So if I were to write this one out, probably a little more cleanly and clearly, I would say that we are taking the derivative with respect to x of x cubed plus y cubed is equal to 6x times y. And that way over there on the right-hand side, I see that product rule of u times v a little more clearly. Right? So I'm going to go ahead and take the derivative. Hey, for this first term, the variable matches the operator, so it's just a plain old derivative. Derivative of x cubed is going to be our 3x squared. The second term, the variable does not match the operator, so I'll need to use chain rule. So I'm going to get the 3y squared times the u prime from the chain rule, the dy dx. Then I run into an equal sign. And then on the right-hand side, I'm going to have to use the product rule. And the product rule says u prime, derivative of the first term, which is going to be 6, times the second, y, plus the first term, 6x, times the derivative of the second. Derivative of the second, well, y and x, different variables, chain rule, dy dx. All right, so now here, I've got a problem. I have 4 terms. No dy dx in this term, no dy dx in this term, dy dx term, dy dx term. So what I need to do is move everything that's got a dy dx to the left and everything that doesn't have a dy dx to the right. Now I don't have to do lefts and rights. I could move the green one to the right and the orange one to the left. It's just most people tend to like it better when you put things on the left. So when I move that to the left, I'm going to get then dy dx times 3y squared minus 6x is equal to 6y minus 3x squared. Okay. So the 6x dy dx, when I move that term to the left, it became negative, and then I factored out the dy dx. Right. Now, Over here on the left, I have dy dx times something. I don't want dy dx times something. I just want plain old dy dx. So I will divide. That gives me dy dx is equal to 6y minus 3x squared divided by 3y squared minus 6x. And then I'll stop and stare at this for a second and ask myself, will this simplify in any way, any useful way? And I'm hoping you're seeing what I'm seeing. We could factor a 3 out of the numerator, both terms, and a 3 out of the denominator to give us 2y minus x squared divided by y squared minus 2x. And then that would be our final answer. So I'm taking derivatives of implicit equations. When I take the derivative of an implicit equation, I take the derivative of each term in the equation. I gather up my dy dx terms. I gather up my non-dy dx terms. I factor and then divide to isolate or to solve the expression, or sorry, the equation for dy dx. Okay. They're just getting more complicated, but that's okay. We can do this. It looks like we got a chain rule on the left and a product rule on the right. On the left, or the sign of something, is cosine of that something multiplied by the derivative of that something. On the right, I have the product rule. The derivative of the first term will be 2y times dy dx times the second term plus the first term times the derivative of the second term. Let's see, technically this left-hand side is 2 terms because of this multiplication right here times this binomial. So this multiplication times this binomial makes that left-hand side 2 terms, and the right-hand side is 2 terms. So let's distribute, clean up, write this thing a little more nicely and see what we got here. On the left-hand side, I have cosine x plus y plus dy dx times cosine x plus y. On the right, I have dy dx times 2y cosine x minus y squared sine x. Okay. dy dx term, bring them all to the left. Non-dy dx term, move it to the right. Factor on the left, I'm going to have dy dx times that cosine x plus y that's already there, minus 2y cosine x that will come from the right, is equal to, let's see, that's going to be a negative y squared sine x minus cosine x plus y. And then, I don't want dy dx times that junk, I just want dy dx. So I'll divide, I get dy dx is equal to negative y squared sine x minus cosine x plus y divided by cosine x plus y minus 2y cosine x. And then, like I've done before, I'll stare at that for a second and ask myself, is there any way to simplify that? And I don't see any meaningful way to simplify it, so there's my answer. What a mess, but there's my answer. I surely would not want to have to evaluate that, because that could get pretty ugly. All right. Natural log of xy plus x is equal to e to the y squared. Again, my job is just to take a derivative. Okay? I'm going to clean this up a little bit over here. There we go, that's a little better. So I can keep it out of my box over there on the right. All right, so my job again is to take a derivative. I see 3 terms. Right? This one's going to be a little bit messy because it's the natural log of a product. This one should be simple, and this one won't be too bad. Hopefully it'll work out nicely. Let's see. What was the rule for the derivative with respect to x of the natural log of u? Wasn't that u prime over u? Because that's what I'm looking at there. Right? So that first term is going to be something over xy, and the numerator is going to be the derivative of x times y. Product rule says the derivative of the first one times the second plus the first times the derivative of the second. Plus the derivative of x is 1. Right-hand side derivative of e to a function is e to the function multiplied by the derivative of the function. Wow, okay. Looks like the right-hand side is just one term that's got a dy dx in it. The left-hand side is actually 3 terms because of this addition symbol right here. Because I'm going to have to rip that fraction apart to make it make sense. Right. So I'm going to go ahead and do that. When I rip that fraction apart, I'm going to get y over xy plus x over xy times dy dx plus 1 is equal to 2y e to the y squared times dy dx. 1 over x, 1 over y. Move this term to the right. Move that term to the left. When I move to the left, I'm going to get dy dx times 1 over y minus 2y e to the y squared is equal to negative 1 minus 1 over x. I don't want dy dx times that junk, so I'm going to divide both sides. I get dy dx is equal to negative 1 minus 1 over x over 1 over y minus 2y e to the y squared. And that is not acceptable because you're not supposed to have fractions in fractions. That's referred to as a compound fraction. So we need to clean that up. So we'll multiply both the numerator and denominator times xy to clear out those fractions, which will give us then negative xy minus y over x minus 2xy squared e raised to the y squared. And that's my derivative, my dy dx. We're at 18 minutes, so I'm going to stop this video here. We'll come back and take a look at this next problem, which looks like it might be a doozy. Find the equation of tangent line to a curve at a point. I'll see you back here for part 3.